go. First of all, let's make sure we're not frightened by the notation. This means the inverse of f of x. So we're going to talk about what that means after we find it. We're going to find it first, and then we'll talk about what that means. We're finding the inverse of f of x. All right, so here's the first thing I want you to do. F of x is the same as y. So let's write it with a y instead of an f of x. Remember, you can always do that. So if the function notation is confusing to you, you can always replace it with y, always. This time I definitely want you to. Because now what we're going to do is we're going to take these two variables and we're going to switch them. So x equals 2y plus 1. Okay? So Jude's needing to turn around. I know he's adorable, but you gotta look at me sometimes, okay? Okay. So we switch our variables. Now, get y by itself. So what would I do now? I have to get, eventually I want this to say y equals. So what do I need to do first here?
Subtract 1.
Subtract the 1. So x minus 1 equals 2y. And then divide by 2. So y equals x minus 1 over 2. And that is the inverse. So the direction said find the inverse is x minus 1 over 2. Now, let me show you, if you haven't already figured it out, what it means to be inverses. Okay? So, Eddie got an A on his test. Make up a number, Eddie.
47.
27. If we take 27 and put it into the original problem, 27 for x would become 2 times 27 plus 1, 55. Okay? Now, come down here to this problem. Put 55 in there. If we put 55 in for that x, what's 55 minus 1? 54 divided by 2 is 27. So what do inverses do? They undo each other. The original function took 27 and changed it into 55. The inverse takes the 55 and changes it back into 27, which makes sense because what was that magic step we did here right off the bat? We switched the x and y. Isn't that what happened? The x and y get switched. All right, okay. Next problem, same thing. Y equals 3x minus 1 over 2. Find the inverse. So what's that magic step? Step 1 is switch your variables. And then once you get them switched, we're going to get y by itself, right? So I heard somebody say multiply by 2. Then we'll have to add 1.
Oh, yeah,
And then we will divide by 3. So for that problem, did you get your answer, your inverse? This was your job, find the inverse. Did you get 2x plus 1 over 3? Everybody okay with that? All right, let's see how far you can get with this one on your own. Try this one on your own, same exact thing. Y equals 4x plus 2 over 9. See what you can do with that. Anybody feel like you got it? You said yes. All right, Eli, come on up. Do you have to put pads under this thing?
Yeah, mine is not the right size. I had to pick either number or size, and I chose number.
Can you breathe when you put pads under it?
Sometimes, other times no, but most of the time. What did they feed you?
All right, here's his answer. Double check and see if it's what you got. He did things in a little bit different order, but it's fine, it's totally fine. Did you get 9x minus 2 over 4?
Yep.
As your inverse. All right, look at the next one now. It's a little bit different. Think of it as y equals.
Square.
Jude, are you stuck on that one, or?
Yeah.
Okay, so he times by 9. I had you switch the variables first. He didn't. Well, yes, he did, I guess. So we multiplied by 4. So that equals 9y minus 2. So we add 2. And then divide by 9. Oh, no, he is wrong. He is wrong. Wait,
Oh, I did it right. Yeah, no. No.
wait.
No, because they flip. They would flip if you do it opposite. If you divide by
Oh,
4,
wait,
multiply
this is wrong right here. Yeah, I don't know what you did. Let me do it. I think this is right. But let's switch our variables, which you did that. Times by 9. Subtract 2. And divide by 4. So somehow you ended up with the right answer.
I just like wrote it different.
But some of that in there was a little whopper jive. But does that make more sense, Jude?
Yeah.
All right, what are we gonna do with this one, guys? This looks different. What are we gonna do? First, we're gonna switch our variables just like always. But now I have to get y by itself.
Square.
I'm gonna have to square it. To make that happen, I'm gonna have to square it and then add 2. So my inverse is x squared plus 2. After you switch your variables, you have to do whatever you have to do to get y by itself. So for Eli, that was times by 9, subtract 2, and divide by 4. For this problem, it was square both sides to get rid of the radical, and then add 2. Do whatever you gotta do to get y by itself. Now, this guy is frightening. We're gonna start the same exact way. So I change my f of x into y, and I'm gonna switch my variables. But what makes this one a little bit harder?
Variables on
Well, there are 2 y's, right? And that's gonna mean a little bit more work for us, all right? Do you have any idea how we might start? What just sort of makes sense, maybe? Multiply by this. So we're gonna have x times 3y minus 4 equals 2y plus 1. Please be writing this down, guys. So first thing we did after we switched the variables, we brought this denominator over here to this side. Now, notice it's in parentheses because it's a quantity. What do you think I'm probably gonna wanna do now? Look at just the way that looks. Distribute. So 3xy minus 4x. Now, this is where things get a little bit whopper-jawed. Here's what some will try to do. Don't write this down. Do not write this down. Some will say, okay, if I subtract the 1 and then divide by 2, I will have my y by itself.
No.
Well, it's true, y is by itself, but what? What's wrong with it? There's a y on the other side, okay? So don't do that. That will be wrong because you can't have y's on both sides. So here's what we do. Rearrange the equation so that every y is on the same side and every not y is on the other side. So I'm gonna bring this 2y over here, and I'm gonna bring this 4x over here. You see what I'm saying? I'm just rearranging my equation. So I have 3xy minus 2y equal 4x plus 1. Basically, I just flip-flop these two. Because I gotta have my y's on the same side. Okay? That's the important step right there. Now that we have our y's on the same side, I'm gonna factor them out. I'm gonna factor out a y. Please don't factor out anything else. Sometimes other things will factor out. Don't do it, because ultimately, don't we want y by itself? Yeah, so don't bring out a 2y or something like that, just bring out y. And then, I'm gonna divide by that parentheses. And there we go. I got y by itself. So I'm gonna have to erase this to do the next problem. These are kind of big. So let's make sure we're clear on all the steps. First of all, I just made f of x and y. And then I flip-flopped my variables. Then I brought this denominator over and did the distributive property. And this is the tricky step. Put the y's on the same side and then not y's on the same side. Factor out the y and divide by the parentheses, and we're done. Okay? Now we're gonna do another one exactly the same. So I want you to see, using what we just did as kind of a model, see how far you can get with problem F. Okay, did you get your variables switched? Okay. Right, then what happens? What do we do now? we bring this over here, right? And when you bring it over, you have to remember to distribute. All right? Then what has to happen? This is the step you cannot forget to do. What has to happen now?
Put the Y's on the same side.
Gotta switch them, rearrange it so that the Y's are on the same side. So, I'm gonna bring my 8Y over here, so it'll be minus 8Y. And I'm gonna bring my X over here, so it'll be negative X. Remember, when they switch sides, they change sign. Right? You gotta subtract X to get it over here. Now what? Greg, I'm not even gonna ask you what you're doing.
Apologies.
Alright, now what happens? Factor out a Y. Notice, this is a problem where you could factor out more than a Y, but don't. Just take out the Y. And then and do that.
I got -2. How did it go from 8 or Y?
It shouldn't have been plus, it should have been minus. Thank you, Michael. She's exactly right. That's a -2 right there. I didn't move him, so that should have stayed negative. You're right, thank you. Anything else we need to talk about there? Before we go to the next step, would you get out a piece of paper? If you don't have any, remember there's some of there behind you, right? Get a piece of paper and let's practice one more of these. Monday's a long way away, but I think maybe on Monday we'll do one of these for a little quiz, just to make sure that we got it. So consider this your practice quiz right here for the one problem. I want you to find the inverse of that. I want you to find the inverse of that. Take a minute. Use your notes if you need to. Try to do as much as you can from memory. I know, we're gonna talk about it, because there are different things you could get. Let everybody catch up here. Did anybody get exactly what I got?
Yes.
A few of you did? Okay, now, see these two right here? They could be turned around. So if you have -5 minus 7x, that's okay. That's the same thing. Does anybody have anything different? Because there still are other answers. I don't want to confuse the issue. If somebody has something different, let's talk about it, because you might be right. Monday, we have a quiz. One problem, just like this. That's what you're gonna do. Okay, so let's talk about the steps one more time. Problem's gonna look like this. Get rid of the f of x and make it a y. Switch the variables, so it's x equals. Then what happens? What's the next step? Bring this over. Now, I brought it over and distributed all together in one step. If it's easier for you, bring it over and then distribute. Then we have the great rearranging step. So brought the minus 3y over, brought the minus 7x over, factored out the y, and divided. Okay? All right. Okay, we're switching gears then. That's as hard as our inverse problems get. So once we get those mastered, we're all set. All right, now look at number 2. 3 questions. Is it a function? Is its inverse a function? Is it 1-to-1? So, let's make a little note. You already know how to tell if something is a function or not. How do you tell if that picture is a function? Vertical line test. So to tell if the original is a function, we use the vertical line test. Some people call it VLT. I'm fine with that, vertical line test. What you may not know is that if you want to know if something's inverse, if the inverse is a function, we use what's called the horizontal line test. So the vertical line test checks your original picture. So let's just do problem 1 since we're there. It's a yes for the first part, right? Now it's a no for the second part because the picture is a parabola, and when I draw a horizontal line, it crosses it twice. Now, that doesn't have anything to do with the original picture. That has to do with its inverse. So the inverse is not a function because it does not pass the horizontal line test. So this was a yes, passes vertical line test. This is a no, flunks horizontal line test. And then 1-to-1 means it passes both tests. So if something is going to be 1-to-1, that means you have no repeated x's and you have no repeated y's. You have one of everything. Well, is this one 1-to-1? No. Doesn't pass both tests. Now, some of you guys are really not very good note takers. see these little notes I made here in the blue? Write those down. Because if all you write is yes and no, when you come back to this in a few days, you're gonna say, why is it yes? Why is it no? Here's why it's yes and no. Okay? Alright, let's look at B. B is a sideways absolute value. If you thought you were done with the BFFs, think again. We're never done with the BFFs. Alright, is it a function?
No.
No. Failed vertical line test. How about its inverse?
Yes.
Is its inverse a function?
Yes.
Yes, because it passes horizontal line test. Think about horizontal lines. It want to pass? Is it 1-to-1? No. Doesn't pass both tests. Everybody with me? All right, one more. Got a little line, a linear function. Is that line a function?
Yes.
Passes vertical line test. Is its inverse a function?
Yes.
Passes horizontal line test. Is it 1-to-1?
Yes.
Passes both tests. All right. I hand you something. How do you tell if it's a function or not? Vertical line test. How do you tell if its inverse is a function? Horizontal line test. How do you tell if it's 1-to-1? Passes both. Okay, isn't it easy? All right. When it shows up on a test or quiz, it's easy. Remember, it's easy. Okay, now we're going to sketch the inverse. Okay, so bear with me here while I figure out this original picture, which is not a BFF, obviously. It's some kind of random thing. And while I am plotting mine, here's what I would like you to do. Write on your paper here, put down the coordinates of each point. So like that one's 0, 1, this one's 1, 0, this one's 2, 2, this one's 3, 0. So write down the coordinates of each point on the graph. You'll see why in a minute. All right, you good? Now, we're somehow going to sketch the inverse of this. So I want you to think about the very first thing we did today. I gave you an equation, and I said find the inverse. What was the first step to that process? Flip the x and y. So, if I want to graph the inverse, boys and girls, I'm going to flip the x and y. So I don't care where you start. I guess I'll just start over here and work my way across. but I just flipped the x and y. So this point is gonna become 0, -4. This one's gonna become -1, -3. Take your time. -1, -2. 0, -1. 1, 0. 2, 2. And 0, 3. I missed one. I missed one. 0, 1. Does that picture, keep working on it, take your time. Does that picture kind of make sense? You think about it? Because in the beginning, all of these shapes were kind of sitting, like this triangle is sitting on the x-axis. Well, when we did the inverse and we flipped the variables, now they're kind of sitting on the y-axis. Right, do the same thing. Please label the points of the original. You don't have as many this time. You okay? Everybody all right with that? So, no matter what weird random shape I give you, you can always find the inverse or graph the inverse. You can always graph the inverse by simply switching the x and y. Perfect. Perfect, perfect, perfect. All right. Here we go. Number 4. Oh my. This is completely different. This is a whole different ballgame. Look at these equations. They have t's in them. What is t? Great question. These are called parametric equations. And t is the parameter. Now, I'm not going to go into heavy-duty detail here, but parametric equations are used a lot in physics to describe the position of an object at time t. So think about this for a second. If I wanted to know, let's say these equations are describing the movement of a bird in the sky. If I want to know where that bird is after 1 second, I could plug in 1 for t, and it would tell me that my x is 3, and my y is -3. So whatever that bird's doing, at 1 second, he's sitting right here. Now, could I find his time then at 2 seconds? And at 3 and 4 and 5? And then if I connected those, I could see kind of a picture of his path. So this is nothing more than plotting points, like you've always plotted points. The difference is your x value and y value depend on this other thing called t. So the question says, find x and y if t is 1. Didn't we just do that? That's your answer. That's it. That's all there is to it. Now look at the next set of equations. This time we're finding x and y if t is 7. So what is your ordered pair, x comma y, if t is 7? 249. How did we get 2? 7 minus 3 is 4, and the square root is 2, and then 7 squared is 49. So, stop. How do we find an ordered pair? If they give us a t value, we just plug the t value back into our equations. And that gives us an x and a y. Alright, we're almost there. We're gonna finish this page and then I'll be done for the day. We've done a lot. Alright. Okay. Now these directions are different. These don't say find x comma y. These say find a direct algebraic relationship between x and y. It's not x plus y, even though it kind of looks that way. It's find a direct algebraic relationship between x and y. Here's what that means. It's so easy. It sounds very hard, but it's so easy. We want to somehow put these two equations together by getting rid of the t. So, what if I divided this equation by -2? Is that legal? Then, what if I took this guy and plugged him in right there? So then what would it look like? X equals 3 y over -2 plus 1? Okay? Now, take a look at this. I know this is kind of an ugly equation. Don't let that bother you. Take a look at this equation right here. Does it have any more t's in it? What are the letters that it has? X and y. A direct algebraic relationship between x and y. That was our job. So that fancy vocabulary, direct algebraic relationship between x and y, just means put the two equations together by eliminating the t. Can we do it again? Alright, so what do we do first? Don't we want to get rid of a t, so let's get t by itself? So it might be easier to do the top equation. So x minus 4 equals t.
Yep.
Why did I get t by itself? So that I can now plug that in right here.
Yep.
So y equals 7, x minus 4 minus 3. I would distribute, this would be easy to clean up. Y equals 7x minus 31 is the direct algebraic relationship between x and y. last one on your own. And let's get in the habit, I did not clean this answer up, because it's kind of a mess. But let's get in the habit of trying to clean up our answers. So when you finally get this problem done, try to clean it up so it looks like this, you know, nice and neat. Sometimes kids wonder, Mrs. Ford, what t should I get by itself? Does it really matter? No. Get the t by itself. That looks like it's going to be easiest for you. Try to get this done.
Do you want us to simplify that, or just leave it as 2y over 6? 2y over 6. But would you accept it if we didn't simplify it?
Alright, so here we go. Which t did you decide was going to be the easiest to get by itself? Top one? Alright. So if I get that by itself, it's going to be x minus 4 equals 2t. So t equals x minus 4 over 2. Is that okay? Now, that is what has to go here. So y equals 3x minus 4 over 2 minus 1.
Why is the 3, is that inside of the fraction or no?
It's 3 times your fraction.
Times the whole fraction?
Yep.
Okay.
But it's 3 over 1.
Yeah.
So the 3 only goes on the top. So that's 3x minus 12 over 2. What about 3x minus 12 over 2? Can I write that as 3x over 2 minus 6 minus 1? Could I do that? So I got 3 halves x minus 7. Now, what other answers did you come up with? And we'll talk about if they're okay. If there are other ways you could come up with something. What, did anybody come up with anything different?
How'd you get the minus?
Yep.
X equals 2 times 1, y plus 1 over 3.
X equals, so you went the other way. So x equals 2 times
Y plus 1 over 3. Plus 4.
plus 4. Okay, so you'll want to distribute that. You're going to have 2y plus 2 over 3. And then you're going to want to split that, 2y over 3 plus 2/3 plus 4. So you're going to get 2y over 3 plus, what is that, 12 14/3? That's what you're going to end up with. Now I want to show you something, because last year, none of the kids wanted to do the problem this way. They all looked at this and said, Mrs. Ford, if the point of the problem is to get rid of the t's, then how about if I multiply this equation by 3 and this equation by -2? So 3x equals 6t plus 12, and -2y equals -6t plus 2. So 3x minus 2y equals 14. That's exactly the same as the equation Giovanni got, and it's exactly the same as the equation I got, just written differently. So in other words, what we were doing was substituting. We were solving for t and substituting in. What the kids last year wanted to do was elimination. Eliminate the t's. Does it matter which one we do? No, you're gonna do whatever's easiest for you, whatever makes sense to you. But the idea is you gotta get rid of the t's. So you're either gonna substitute them out, or you're going to flat out eliminate them. Okay? Grant?
On your equation, how did you simplify 3x minus 12 over 2 into 3x over 2?
Because it's 3x over 2 minus 12 over 2. Both of these are divided by 2. And then my equation comes out in second or second form. Believe it or not, that's a line, and now we know it is because it came out that way. Hey, I'm going to give you a couple of things to get ready for next time. Just some graph paper. So everybody's going to take a couple sheets of graph paper. Because we're going to be doing, next class will be all graphs. It's going to be a million graphs. And we're going to use some paper. What also happens next class, the quiz. We have a little one problem quiz. Also, we just finished 1-5, so that homework will be due on Tuesday. So 1-5 homework due on Tuesday. All right. Yeah, I mean, you need to get on it, get it out of the way, but you don't have to do it Monday.
Yeah, because I know I wouldn't be able to make it. Because I leave.
Yeah, that's fine, that's totally fine. I don't want you to take it until you're ready.